camera, and every time you're looking for one of those things, you're looking for the one with the largest amount of pixels. And the reason you want the TV with the largest amount of pixels or the camera with the largest amount of pixels is because it gives a really, really clear image. And that's what my magnet does. It gave me really, really clear images of the different chemicals that I was studying. So yeah, if you ever get a chance to visit Tallahassee, Florida, I would recommend you check out the National High Magnetic Field Laboratory. And so after graduating from Florida State and coming to Yale, I thought a lot in between about what I wanted to do. And a lot of that had to do with my family background. So I come from a family that values owning land and growing our own food and raising our own animals. And so we have a farm. And here's a picture of our mule, one of our baby lambs, some okra that we grew, and some purple hull peas that we also grew. And so in addition to thinking about my home, I thought about some of the places that I got the opportunity to travel to, like California. I was able to see the beautiful landscape and see seals in person without having to be in a zoo. And then I also thought about Yale and this place that's really beautiful where people and nature can interact together. So all these things together helped me make a decision to focus my research here on preserving the environment. And so with that, we'll give a brief outline. So we're going to talk about how widespread global climate change is. We're going to talk about some of the sources of it. We're going to also focus on how we can use chemistry, or how I use chemistry, to fight climate change. And we're going to talk about some ways we can make a difference. Some of the learning objectives for this talk are being able to describe the effects of global climate change, being able to identify greenhouse gases, understanding that redox reactions involve an exchange of electrons, and identifying different ways we can reduce greenhouse gas emission. And so with that, we'll go ahead and get started. Okay, so how widespread is global climate change? I'm sure you guys have seen images of hurricanes and firestorms, but what else comes to mind when you think of global climate change? All right, I see forest fires, good, good. Heat, great. Polar bears, heat waves, wow, I love the activity in the chat. This is awesome. Rising of the sea level, awesome. Acidification of oceans, wow, you guys are experts. You guys don't need me, you guys are experts. Awesome, awesome. Tornadoes, white coral, great, great, awesome. Well, I'm so excited to see that you guys know so much about climate change. One of the few examples that stood out to me when I was researching this topic was actually one that wasn't so familiar. And one of you guys in the chat mentioned the mosquito. So why might there be a mosquito, and how does that relate to global climate change? Well, as temperatures rise, the breeding season of mosquitoes is actually a lot longer. And so you can have more time for mosquitoes to go around spreading disease. And so, you know, that's why having higher temperatures can result in more disease spreading to more and more people. So yeah, that's another consequence of global climate change. Yeah, mosquitoes are the worst. I agree. All right. So what are greenhouse gases? What can you guys tell me about greenhouse gases? They trap heat in the atmosphere. Awesome. CO2, carbon dioxide. Great. Gases coming out of cars and factories come from gases like gasoline. Awesome. Methane. Wow, you guys are, I am so impressed. You guys are awesome. Wow. Wow, great. Great answers. Thank you so much. And you guys are exactly right. They're gases that trap um, heat in the atmosphere. So that's awesome. Can you name some greenhouse gases? I know a few of you guys named methane and carbon dioxide. Great, great. Do you guys know of any other ones? Okay, all right. See, sulfur dioxide, carbon monoxide. Okay, okay. I like these ideas. Good. Ozone. Okay, great, great. All right. So some of the greenhouse gases are summarized in this pie chart here. And so we have carbon dioxide, which you guys, were spot on with that one. And it comes from the exhaust out of your car. So you burn gas and you get exhaust smoke coming out of the back end of your car. And that has carbon dioxide in it. And it also has another greenhouse gas that you probably aren't as familiar with called nitrous oxide. So that also comes out of that exhaust smoke. And so some of you guys also mentioned methane, which is great. Have you guys ever driven by a trash dump and you can smell it before you get there? Has that happened to anyone? Yeah, I can see. Yeah, yeah, lots of yeses. Well, that gas, that smell that's coming off is methane. Methane from all that trash that's collected all around town. So when you think of methane, you can think of the gas coming off of our waste. And then there's another greenhouse gas called fluorinated gases. Um, which are in the cooling system inside of your refrigerator. So they are the least abundant, or they're least of them in the atmosphere, but they cause the most trouble because they stay in the atmosphere the longest and they trap the most heat. So great. I noticed one of you guys also mentioned cows give off methane. Absolutely, absolutely. All right. So some of you guys mentioned some examples in the chat, but where do greenhouse gases come from? Cars, burning fossil fuels, factories, refrigerators. Good, good. Yeah, we kind of talked about it a bit on the last slide. Great. Cows, humans. Awesome. Awesome. Right. So we all know it's pretty cold outside. So what are we doing? We're burning a lot of heat. We're using a lot of electricity to stay warm. So, roughly 25% of our greenhouse gas emissions come from heat and electricity. Then another chunk comes from agriculture and land. So all that food that we're growing to survive using it also produces a lot of greenhouse gases. And then you have industry, those factories you all were talking about, transportation, how we get around, and even some quite a bit, almost 7% comes from food waste. So, all that food we don't finish and throw in the trash dump, that also contributes to greenhouse gas emissions. All right. So now we're going to break out into our different groups, our breakout rooms, and you're going to have two activities. The first involves you discussing different foods and why one food versus another may have a larger impact on greenhouse gas emissions. And then the second activity, if you have time to do it, involves figuring out what your carbon footprint is, which is basically how much are you contributing to the emissions of emissions of greenhouse gases. So with that, we will break out into our groups and we'll come back and talk about it, okay? Now that everyone's back, what do you guys think of the activity? Were you surprised at your choice? Did your choice end up being the largest contributor to greenhouse gas emissions? Right. Great. Great. You were shocked? Okay. I was shocked as well when I saw that. Some people thought fats and sugars should be a lot higher. Right. I thought as well that candy should have been the higher one. All right. Great. Great. I wasn't surprised veggies were lower. Okay. Okay. Great. I'm glad you guys seem to enjoy the activity. Um, but just to review it, red meat or beef, for example, contributes the largest amount to greenhouse gas emission. And from that, you think of the energy you put into raising cattle, into butchering the animal, transporting it. So all that is summarized in this number. And then chicken is kind of in the middle. Fish is a little bit higher. Yeah, some people didn't think fish would have probably been as high as it is, but you have to think about how much energy you take in catching the fish, and then you have to transport it. You have to keep it cold. Yeah, so there's a lot that goes into it. And then the probably one of the more surprising ones was that fats and sugars are so low, even though they're very processed foods. You make them in a factory, but yeah, they don't contribute as much to carbon dioxide emission. So yeah, I was also shocked by that as well. And did you guys end up making it to activity two, where we talked about our carbon footprint? Okay, great, great. I'm happy to see you guys made it there. So, yeah, so your footprint is simply, how much do your daily activities add to the amount of carbon dioxide in the atmosphere? And so I think doing this activity kind of helps you see where your household is in terms of greenhouse gas emissions. And it can kind of help you see if you're above the average or below the average, and see how you can adjust your activities to make sure you aren't contributing too much to um, carbon dioxide emission. So great. And yes, I will make sure to put the link in the chat, so you guys, great. Thank you. Thank you. So yeah, so I want you guys to all do this at home, and talk to your parents, talk to your family about it, so you can all kind of figure out where you stand in terms of your greenhouse gas emissions and your carbon footprint. So great, great. I'm happy about that. All right. So something we all have in common is we've all experienced this COVID-19 pandemic. And in that, pretty depressing situation, we've all um, been able to observe a little glimmer of hope. And in that glimmer of hope is kind of summarized here. And so I came across these two pictures watching the news. And so the first is a picture of the India Gate War Memorial in New Delhi, India. And it was taken in 2019, in October of 2019. And so there you can see the background of the picture is really foggy. The air looks extremely thick. It's hard to see pretty much anything in the picture because the air is so thick. And that's because of air pollution and smog. Right, great. Someone mentioned the worst. It has the worst smog in the world. Yeah, I'm sure that air looks terrible. But when people weren't moving around and there was less traffic, less congestion on the roads um, during the lockdown, the air pollution was reduced. You could clearly see the color of the sky. You can see the memorial. So that's one of the silver linings of this COVID-19 pandemic. And so thinking about air pollution and the impact of changing our behavior as a collective unit of all of us working together, we can make a big difference. One of the big efforts people are working towards is using renewable energy to help fight climate change. And so renewable energy is energy generated from natural resources like the sun, the wind. But the issue with these natural resources is that they're not always available. So for example, like right now, you might have solar panels on your house, but there is no sun outside because it's night. And so you're not producing any solar energy. And so what we need is a way to store the energy that we collect during the day when the sun is shining, for example, and store it for later use, for example, at night when the sun isn't shining and we still need electricity. And so the goal of my research is to use chemistry to combat climate change. And the way that I intend to do that is by providing a solution to the renewable energy storage problems. And by doing that by changing carbon dioxide into fuel. So carbon dioxide we've been talking about is a common greenhouse gas. So the goal of my work is to change it into a fuel like methanol or ethanol. And so the way I do that in my research lab is I have this system where I have two chambers that are separated from each other, and they're connected to a battery, which provides a source of power. And then one of the chambers, I flow carbon dioxide into it in a special chemistry reaction or chemical reaction happens in that chamber to change carbon dioxide into a fuel. And so the fuel that we are able to make is methanol or ethanol. And you guys have probably heard of ethanol or methanol, probably at the gas pump, right? Right, great. So, if you're at the gas pump with your parents, they'll have different types of gasoline and they'll have different amounts of ethanol, for example. So that's the fuel that I'm trying to make. Right, awesome. And so how will this be done? So I'll be able to change the gas carbon dioxide into a liquid fuel using something called an electrochemical carbon dioxide reduction reaction. And that means it'll involve electrochemistry. And so electrochemistry means that I'm using electricity or moving electrons to do the chemical reaction. And so that's why I have these two compartments connected to this battery source. All right. And so the other part of that term that I said, electrochemical reduction reaction, is redox. So a redox reaction is a type of a chemical reaction that involves the transfer of electrons. So have you guys ever been trading cards, whether they're, baseball cards or Yu-Gi-Oh cards or whatever kind of cards you guys like? Awesome. Pokemon. Great. So take that idea. So we're going to be trading but instead of trading cards, we're going to be trading electrons. And so electrons are tiny negatively charged particles. And we're just going to be taking one electron from one partner and giving it to another. And we're just going to be trading back and forth. And so when I was first learning about redox reactions, I learned about an acronym called oil rig. And so oil stands for oxidation is the loss of electrons. And rig stands for reduction is the gain of electrons. So that's what I mean by that exchange. Something is losing electrons, something is gaining electrons. All right. So now we're going to go chamber by chamber. So what's happening in the oil chamber? So the oil chamber is going to be on the left. And so in the oil chamber, we're taking water and it's changing into hydrogen ions, electrons, and oxygen gas. And the full chemical reaction is water, 2 hydrogen ions, 2 electrons, and 1/2 of oxygen. And so in this situation, water is being oxidized. So we're going back to our acronym. In oil, oxidation is the loss of electrons. So when we're in the left compartment, the left chamber, we're doing oxidation. So we're losing electrons. All right. So in the right chamber, we have a different reaction happening. So in the right chamber, we're in our rig chamber. So this is where reduction's happening. And so we have carbon dioxide, hydrogen ions, and electrons changing into carbon monoxide. Have you guys ever heard of carbon monoxide? Yeah, carbon monoxide. Yeah. Carbon monoxide is pretty dangerous. It's the reason why you need to have smoke detectors in your house because it detects carbon monoxide, which is really, really poisonous, very dangerous, and water. And the full chemical reaction is CO2, carbon dioxide, hydrogen ions, 2 electrons to carbon monoxide, and water. And so in this chamber, carbon dioxide is being reduced. And so you might be wondering, didn't Nia say we were making fuel? Well, why is she talking about making carbon monoxide, which is a gas? Well, carbon monoxide, this first reaction is just one step in a multi-step reaction. And the end goal will be the ethanol or methanol fuel. But you're right, this first step just produces a gas. So it'll take multiple steps, multiple reactions in order to get to the fuel that I talked about. And so as a reminder, this is rig. Reduction is the gain of electrons. So that's what happens in our rig chamber. All right. And so now we're going to put everything together. And so we have our system here. We have our oil chamber where oxidation happens. So oxidation is the loss of electrons. We have our rig chamber where reduction is happening. And so reduction is the gain of electrons. And if you zoom into what's happening in this reduction chamber, you have a place where a catalyst, which is a substance that speeds up a chemical reaction, comes in contact with the carbon dioxide and comes in contact with our electrolyte, which is salt water. And they meet at this special spot. And in this special spot, they do the chemistry that's required. They do the reduction reaction in order to produce the fuel. And so here we have our catalyst, which speeds up the chemical reaction. And then we have our carbon dioxide coming in, making contact with the catalyst, which is also making contact with the electrolyte. And then we can produce a gas as our product. But we can also produce what we really want, which is that fuel that I was talking about. So you can also, in addition to making, gas products, our goal is to make that liquid fuel like ethanol or methanol. And so some of the questions I think about while I'm doing my research is, number one, how do I make more fuel? How do I make more ethanol and more methanol? And number two, what's special about my catalyst that helps me make more fuel? And so those are the things that I like to keep in mind when I'm designing different experiments. And so now that we've talked a little bit about, global climate change, we've seen, how I work to tackle that problem using chemistry, and other chemists as well. But now, we need to think about what we can do together to tackle this problem. And so the image, the picture of the India Gate Bridge War Memorial really showed us, that if we all work together to make a difference, we can make a big impact. Maybe one person making a change might not make as big of an impact, but if we all work together, we can make a big difference. And some of the ways we can reduce global climate change are to simply, when you leave a room, turn off the TV, turn off the light switch, change out old light bulbs and use energy efficient ones. Use a little less hot water, plant a tree, or recycle. So these are just some of the ways that we can all work together to help reduce global climate change and make a difference for all of us. And so with that, I'd like to thank you all for listening and having some awesome comments in the chat box. And I would like to open the floor for any questions.
Awesome, Nia. Thank you so much. I think we all learned a lot, even though the students already knew so much. So we had a few questions in the chat. So one of the questions was about, is it true that global warming can lead to localized cooling? So I think this was from your earlier picture.
Yes, yes. So I actually watched a documentary in high school about that's why people aren't using the term global warming, because it can actually result in global cooling as well.
Okay.
So yeah, that's actually true.
So the other question is, so we had a lot of questions about greenhouse gas emissions. So does food waste contribute to greenhouse gas emissions?
Yes, yes. So a little further back on one of the previous slides, you can actually see that the food waste, so just food, maybe you weren't hungry and you just didn't finish it all. You're still contributing to greenhouse gas emissions. And a lot of it is methane, but also CO2 as well. So you can see from this diagram about 7% food waste contributes to greenhouse gas emissions.
Okay, so we should eat all our food.
Eat all your food, or buy what you're going to eat, or buy the things you will eat.
So we had a lot of questions about the redox reaction that you showed. And so one of the questions was, is oxidation related to chemical weathering?
Yes. When you think of, for example, rusting, like rusting on a car, that's an oxidation reaction. So yeah, there are examples all around us of oxidation reactions. They're even happening inside your body. So they're all around us. Yeah, that's awesome.
And then we had a question on the image that you showed of the catalyst and your electrolyte colliding. So I think the question was, what happens when they collide?
Ah, okay. So this is the thing that's quite interesting and still being understood. But basically, you have to have a a special material, a special substance called a catalyst, and it has to interact with the carbon dioxide and the electrolyte in just the right way to allow the right reaction to go forward. So there are some reactions that will only produce carbon monoxide and won't continue to do the rest of the steps to produce the fuel. So there's a lot of chemistry there that is currently still being studied. My lab here at Yale studies it, trying to understand how to make that Goldilocks situation to make the fuel. Yeah.
Really interesting. So yeah, so we don't have all the answers. And then we had another question about the oil rig battery. So the picture you have on the left. So are they efficient, and how do they compare to other batteries such as lithium ion batteries?
So technically, this is called a cell, but it has two chambers. So it's not, the battery we use here is not, it's just a normal like battery voltage, like for example, you put in your remote, like a normal battery. It's just supplying the energy needed to do the reaction. And a lithium ion battery works in the same way. It supplies energy, but the chemistry behind a lithium ion battery is a bit different. This is more of a traditional battery. It's not super special.
And so, how efficient would you say it is compared to the regular batteries?
Um, I would say it's a traditional battery. There's nothing special about it. The lithium ion batteries are specifically used for, making sure your, phones and laptops have a long battery life. Um, and this one isn't specifically made for that. It's just made to uh, control a voltage or supply energy. But the batteries you hear about on the news and on TV and marketed in different devices are supposed to have long life. And this one isn't made for that purpose.
I see. And then one last question about this chemistry. What was it? Oh yeah, is there much waste in this chemical process?
Um, Unfortunately, working even in a lab, you generate quite a bit of waste. A lot of our waste is at least non-toxic, at least for the reactions that I do. They're done in salt water, so they don't really add a lot of more dangerous chemicals to the waste. But yeah, working in a lab, you end up generating a lot of waste in terms of gloves and pipettes and tools you use that get disposed of. So you do generate a lot of waste to do chemistry.
Hopefully, in the end, after we do all the trial and errors, you can reduce the amount of emissions. So finally, we had a couple of questions on how we can reduce our individual footprints. So you talked about maybe planting more trees. And so the students had questions on whether is there a certain tree you should plant, where should you plant them, and if you plant too many, will we deplete all the CO2 in the atmosphere?
Yeah, I think planting anything, or even if you just have little pots in a windowsill, that even the little plants contribute to reducing some CO2. But I don't really think it's a specific kind of plant. All plants are should be okay, especially the ones you can purchase at like a Walmart or a Lowe's somewhere. Should be fine. But yeah, the biggest thing you can do is to try to restore some of the trees that have been taken down to build houses and build schools and whatnot. So putting some back is definitely something that I think is important.
Awesome. So I think that was most of our questions. So with that, I'll hand it over to the outro.